Welcome everyone. The question is an AC source generating the voltage E equal to E0 sine omega t is connected to a capacitor of capacitance C. Find the expressions of the current I flowing through it. Plot a graph of E and I versus omega t to show the current is ahead of the voltage by pi by 2. So here, obviously, this is a circuit diagram where an ideal capacitor is connected of capacitance C, and IT current is just coming out from the source and it is flowing through the capacitor. Then obviously, the charge across the capacitor is changes. Okay, charge across the capacitor is changes with time, and that you can say that is changes with time, and it can be written as QT equal to capital C into VT. Okay, the voltage which is changing across the capacitor, due to this charge across the capacitor is continuously changing. Now what is the voltage applied across this capacitor? That is E. E is the voltage applied across the capacitor plates. So that is E equal to E0 sin omega t. So I can write it down. It is simply capital C into E0 multiplied by sine omega into t. Now, if I just differentiate this equation, then we get simply the current. Obviously, it is a small I, and that is obviously changing with time. So it is I equal to dq dt. I equal to dq dt. So you can say it is ddt of capital C into E0 multiplied by sine omega into t. So C multiplied by E0 sine omega t, on which the differentiation may work on, that is ddt of sine omega into t. So this will be C E0 sine omega t becomes cos omega t, and the differentiation of omega t will become omega. So this will become omega C E0 cos omega t. Okay. Now it is said find the expressions of the current. We have obtained that. Find the expression of the current. Plot a graph of the E and the current versus omega t so that the current is ahead of the voltage by pi by 2. So that the current is ahead of the voltage by pi by 2. So let us write it down two things. That is the voltage across the capacitor, which is denoted as Vt, which is later we have write it down, it is E0 sine omega t. And the current and the charge which is appeared across the capacitor, that is Qt. Qt is equal to omega C E0 cos omega t. So this will become omega capital C E0 cos omega t becomes sine omega t sine omega t plus of pi by 2. It is simply trigonometric relationship of trigonometric relationship if the two angles sum is 90 degree, the complementary angles, that is sine omega t plus theta, sine 90 degree plus theta is equal to cos theta. That simple equations I have used here. So sorry, it is not q, it is I. Expression of I have written here. So it is equal to omega c epsilon 0 or e, not epsilon 0, it is e0 sine omega t plus pi by 2. So this becomes I0 sine omega t plus of pi by 2. Okay, so obviously if I try to draw this, then simply the voltage is the sine function but the current is the cos function. So if I try to plot the voltage and the current, okay, then just try to understand that I0 is equal to omega, I0 is equal to omega multiplied by C into E0. So obviously here if I just try to say that E0 divided by 1 by omega C, and 1 by omega c is nothing but the capacitive reactance, which is denoted as xc, which is equivalent to that of the resistance in the if the resistance is present there, xc is just acting like the resistance. If the capacitor is there, then in AC the reactance is acted on, which is reduces the current. Okay, it is observed from this equation, that is I0 is equal to E0 divided by xc. So now if I try to plot the current, if I try to plot the current is something like this. Okay, current is something like this. No, this is the voltage. The voltage is something like this. E to the equal to sine omega t. This represents the sine function. So here I have plotted the voltage. But if I plot the current will be little bit less than that of it, and it will be a cos function. So it will be looking like this. Okay, so it will be looking like this. So obviously this value basically gives you the current, that is the maximum magnitude plus I0, and this is the minimum one, that is minus I0, and this basically gives you the plus V0, and this basically gives you the minus V0, and this is with omega t. So obviously it shows that the sine function and cos function, the sine functions represents the voltage and this cos function here represents the current. If I try to plot it in phasor, then obviously we can do it like this way. This is the voltage. This is the voltage phasor. This is basically represents the supply voltage, and the current phasor is ahead of that. The current through the circuit, it is pi by 2 ahead of that. This is the phasor diagram. That's why this is written in caps. Okay, this is called the phasor diagram. That basically denoting what is the phase difference between the voltage applied across the capacitor and the current passing through the capacitor. That is